Hi everyone. So in today's video, we're going to be learning about the grade 10, chapter 6, hydrocarbon derivatives. So if you remember in our last video, when we talked about the organic compounds, we said that organic compounds classified into two branches. The first one is the hydrocarbons and hydrocarbon derivatives. So in that video we talked about the hydrocarbons, the hydrocarbon classification, which is out of the aromatic and the aliphatic one. So the hydrocarbon derivatives, today we're going to be talking about that. So the hydrocarbon derivatives are oxygen containing compounds. So in this chapter it talks about the nomenclature and also the physical properties, the chemical properties of those hydrocarbon derivatives which contains an oxygen, and are also called oxygen containing hydrocarbons in our chapter. So in this lesson we're going to be seeing the key pointers that is based on for exams. So let's start from the alcohols. So alcohols are basically an OH groups. If you see an OH group in the carbon chain, then it's an alcohol group. So alcohols are classified into four groups. So there are monohydric, trihydric, dihydric, and polyhydric, based on the OH group they contain. If they contain one OH group, then it's called monohydric. If it contains two, it's called a dihydric compound. And if it's three, then trihydric. It's more than three, it's going to be a polyhydric. So in monohydric, they classify into three branches. And primary, secondary, tertiary. So primary is when the OH group is attached to the first carbon. For example, let's see, 2H2, CH2, CH3, CH2, it goes on. So if the OH groups are attached here, then it's a primary. If it is attached in this side, it's secondary. If it's attached in there, which is going to be tertiary. And the common name for the alcohols is alkali alcohol, which is basically methyl alcohol, ethyl alcohol, and goes on like that. And for the IUPAC naming, just replace E with ol. Methane is going to be methanol. Ol, the ol suffix is added. If it was ethane, it's going to be ethanol, which is a universal solvent. And ethanol is the basic constituent in beverage soft drinks. So the physical property is that it has a high boiling point due to the hydrogen bond, because of the hydrogen bonds that found in the chemical structure, in the chemical formula. So as the OH group increases, then the boiling point is also going to be increasing. But the less OH group it has, the more highly it's going to be dissolving in water. So the preparation is that an alkene plus a water is going to be an alcohol, and hydrolysis of an alkyl halides, which is used by Markov-Liebowitz addition rule. So we see that in our next video how we're going to be using the Markov-Liebowitz. So the name is actually kind of difficult to pronounce, you know. My native language is not in English. That's why I'm actually not very good at English. So don't mind my accent. So Markov-Liebowitz, an addition rule, is where the alkyl halides is going to be hydrolyzing with water. So those are going to be a formula. Let's just say the formula how the OH group is going to wear, and the H1, the hydrogen, is going to be where. We're going to be seeing it in our next video. I'm going to make another video based on mainly the Markov-Liebowitz addition rule. And the other preparation way is the esterification. So hydrolysis of esters. If we hydrolyze the esters, we can find an alcohol. For example, ester plus potassium hydroxide is going to give us an alcohol. And in alkyl halides, sodium hydroxide, alkyl halides plus sodium hydroxide is going to be given as an alcohol. And let's move on to the chemical reaction. So chemical reaction, oxidation reaction. So primary alcohol oxidized into aldehydes, secondary alcohols oxidized with ketones, but the tertiary alcohols, when oxidized, they are going to be not affected. There is none. They do not react because they are highly stable, and also they are highly, or there is the dehydration extent is high, which means that they are more reactive. So they cannot oxidize at the tertiary alcohol. So in that case, the stability also going to be increasing. The stability, the dehydration extent is increasing. And as also here, dehydration of concentrated sulfuric acid at 170 degrees Celsius produces an alkene. See? If we use an alkene plus a water, is going to give us an alcohol, right? So if we dehydrated it, we're going to be removing the water from the alkene. What we added in the first place, we added a water in the alkene and we found an alcohol. So if we remove the water, it's going to be to original point, which is an alkene. So at 170 degrees Celsius, we're going to be getting an alkene. We stated this degree Celsius because they're going to be varying results. So we're going to be seeing it. So the second one is not this one. Let me grab. So here it is. The second one is an ether. So ethers are an oxygen that are surrounded by carbon chain. So it's just oxygen surrounded by carbon chains. So if you see, for example, it's going to be CH2O, CH3, CH3. So this is basically an ether. So for the common name, we're going to be saying alkyl plus an ether. So which is going to be, for example, ethyl methyl ether. So let's look at this one. It's going to be methyl ethyl ether. And for the IUPAC naming, it's going to be met-oxy. So met-oxyethane, which is alkoxyethane, the alkoxyalkane. This one is the formula. So for the ethers, we're going to be saying met-oxy. This one, ethane. Let's look at this one. There's a methyl ethyl. So we're going to be seeing the longest one. So we're going to be the smallest one is going to be met-oxyethane. Like eventually the structure that I used is actually the same for this one. It's met-oxyethane. And for the physical properties, they have low boiling point. They have low boiling point because they cannot form a hydrogen bond and they are volatile. They do not form a hydrogen bond because they are only an oxygen surrounded by a carbon chain. So it's basically not bonded with hydrogen. So they are volatile and a good solvent, which basically they are organic solvents. And as I told you, the 170 degrees Celsius is actually essential because at 140 degrees Celsius, we're going to be getting an ether. So dehydration of an alcohol at 140 degrees Celsius is going to be giving us an ether. And dehydration of an alcohol at 170 degrees Celsius is going to be giving us an alkene. See the difference? So those degrees Celsius are essential. And two alcohols are going to be giving us an ether. And there's a Williams synthesis process, which is when the alkali halides halides, which means halogen groups, which means that a carbon chain that contain a halogen group, a plus an alkoxide. Alkoxide is just that of, for example, sodium hydroxides might be, when they both form, they're going to be given as a nature. So basically, it are a good solvents. They are volatile. They form. They are formed by dehydration of alcohol at 170 degrees Celsius. Do not forget this degree Celsius, because it's actually the basic thing that also mostly an exam based. So NB, as I stated here, at 140 degrees Celsius there's ether, and 170 degrees Celsius an alkene is formed. Do not forget about that. So the third one is an aldehyde. So an aldehyde are just like a carboxylic acid, which we're going to be seeing later on this video. So aldehydes have, at the end of the chain, they have double bonded to O and OH. So carboxylic acids, as I told you, they are bonded at the end of the chain. They are double bonded to O and OH, while aldehyde, just like the carboxylic acid, they are bonded with double bond O and H. So the common name for aldehyde is just that the simplest one is formaldehyde, and then the acetaldehyde and propaldehyde. So you only need to know the three of them. Actually, it's going to be the same: butaldehyde, pentaldehyde, hexaldehyde, heptaldehyde. Just add aldehyde at the end. That's common name. But mostly in exams, they are going to be asking the simplest one. The simplest one is actually essential for your exam, because most exam based are going to be contain formaldehyde, most of it. So it's going to be formaldehyde is the simplest one. And for the IUPAC naming, just replace methane, if it was methane, N, with al, the suffix al. So it's going to be methanol, ethanol, propanol, butanol, anol. So the other one is a ketone. So the ketones are only double bonded with O. What makes them different from the aldehyde is that they are only double bonded with O, and they are not. They can be at any position in the carbon chain. They can be at the end or at the middle. But aldehyde are only at the end, do not come in the middle. And for the aldehydes are double bonded with O and H. They have an hydrogen group which is attached to the carbon chain in here. But in this case, it's carbon chains attached to O only, and it's not hydrogen. It's going to be CH, and just let's call it an R group, basically. So the common name is alkyl ketone. So it's just that the simplest ketone is acetone. The simplest ketone is acetone. Do not forget about this. The simplest one which I stated are those which going to be coming your next exam. Might be, who knows, but it's mostly chem. And the IUPAC naming for this one is 1. If it was butanol, propanol, pentanol, 1. Just add the suffix 1 at the end. So aldehyde and ketone have high boiling points than the alkanes because of the dipole-dipole interaction. So here, ketones smell sweet. They're usually used in perfumes. So that's why they're sweet. And the other functional group is that esters. So esters, for the common name, they are ethyl formate, that's the simplest one, and ethyl acetate, just ethyl formate, ethyl acetate. It goes on like that. And they have the IUPAC naming is that acetic. No, it's good. Just add at the end H, the suffix X is going to be metate. Etate is going to be hetate at the end. And for example, for that they have fruity smell. They are usually found in fruits and they have pleasant odors. They have low boiling points than the carboxylic acid. Eventually, carboxylic acids have a dimers. We're going to be seeing later when we talk about carboxylic acid. So acetic acid plus ethanol is going to be giving us ethyl acetate, which is the simplest ester. So, which means that this is also called, the preparation is that hydrolysis with water. So if you hydrolysis this with water, which means that if you add water to an ester, we're going to be finding it carboxylic acid and alcohol. This is a reversible reaction, which is just that esterification. So carboxylic acid plus an alcohol is going to give us an ester plus water. And there's the second one is spontification process. So the spontification with base is going to give us a carboxylic salt and an OH, which is an alcohol. This makes a soap, and it is irreversible. So let's move on to our last carboxylic acid, to our last functional group, which is carboxylic acid. So carboxylic acid classify into two. So the common name, which is the cyclic one and an acyclic one, which is non-cyclics. So the common name for both of them have different names. So for the common one, for the cyclic ones, is if you see the structure, it is benzene with carboxylic acid. So the common name for this is going to be benzoic acid, and benzene carboxylic acid is for the name of this structure. So this is actually the IUPAC naming of this structure. The common name is benzoic acid, So if we see that, and for the common naming of cyclic one, we're going to be following the structure orta, mega, para. So it might be there is going to be a methyl group 3, which is NH3, and bromo here. So we're going to be saying O as a prefix, and O, and then it's going to be bromo. So actually I'm going to make another video on the nomenclature of all those 8 functional groups in my next video. So it's going to be clearly for you if you're going to be seeing my next video. Make sure to do that. And for example, look at this one. It is a cyclic benzene, cyclic one, attached to a carboxylic acid. So it's going to be cyclohexane carboxylic acid is the IUPAC name for this structure. And for the non-cyclic one, which are the linear chains, is going to be, the common name is formic acid, which is usually found in anths, and the acetic acid, which is found in vinegar, butyric acid, which is found in butter, and propionic acid, and the lastly is going to be pentonic acid, heptonic acid, and it goes on just based on this pattern. And the IUPAC name is just that, use iuic acid as a suffix. So it's going to be methoic acid, etoic acid, butyric acid, propionic acid. Just use the nomenclature of just like that of an alkane, alkene, alkyne, as we saw in our last video, and we're going to be using it. If we see a carboxylic acid, just change the suffix to oic acid instead of an alkane, alkene, alkyne. That's all you need to know. And so the property of the carboxylic acids, they have high boiling point because they form a dimer. So dimer is when two molecules held by 2 hydrogen bonds. So the small ones are soluble, but as the carboxylic acid increases, the molecular mass is going to be increasing. So which means that the boiling point is also increasing. That's all you need to know. And for the chemical properties, that when carboxylic acids comes with metal, they're going to be giving us salt and water. And when the carboxylic acid plus sodium hydroxide, which is a base, is going to be giving us salt and water, which is basically a neutralization reaction. And lastly, when carboxylic acid plus carbonates or biocarbonates, they are going to be giving us salt plus water plus a carbon dioxide. And the another one is, as we saw it before in the esters, carboxylic acid plus an alcohol is going to be giving us an ester, which is an esterification. The whole process is an esterification. And the preparation is that when the primary alcohol oxidizes in highly reactive catalyst, it must be in highly reactive catalyst, for example, in the manganetes and sulfuric acid, because they need to be oxidized in highly conditions. So primary alcohol oxidizes to give a carboxylic acid. And that's all for the functional groups. And lastly, we have an addition key in this chapter in grade 11, chapter 6, which is about fats and oil. So fats and oil are traces of a glycol. So fats and oil, the difference is that fats are saturated and oils are unsaturated, which means that at room temperature fats are solids, but at room temperature oils are liquid. And that's why liquids are unsaturated, they're going to be liquid at room temperature. The key difference is here. So soap are made by spontification. So spontification is that when we use the irreversible reaction of carboxylate, spontification of esters with base, which give us a carboxylate salt and an alcohol, which is a. So if you paid attention up to here, we talked about in this video about the hydrocarbon derivatives, which are the alcohols, their physical properties, chemical properties, and preparation. And we talked about the ethers and aldehydes and esters. And don't forget about those 2 degrees Celsius, which are 140 degrees Celsius and 170 degrees Celsius. They are key parts. And we also talked about the carboxylic acid